So recently we've been talking about radians as a way to measure angles or talk about an angle measurement. So today what we're going to do is look at some conversions and then use that same concept to be able to convert radians to degrees. So if I said, what's pi over 4 radians, you'd be able to convert that into degrees. So um, just to review what we've been doing so far this year. So if you're adding fractions together and you need a common denominator, we've talked, there's a quick way of doing that. And we're going to multiply by 7 over 7, and the value of 7 over 7 is 1. So in doing that, I'm not changing the value of 2/3 at all, because I'm just multiplying it by 1. And then this 1/7 over here, if I multiply it by 3 over 3, I'm not going to change the value of 1/7 at all, because 3 over 3 has a value of 1. So when I do that, I'm looking at 14/21. So 14/21 and 2/3, exact same value, just a different form. We've converted it, if you want to think about it that way. And then plus, instead of 1/7, we're going to look at 3/21. So 3/21 and 1/7 are equivalent. I've just converted that fraction to look a little differently, and the purpose here is so that we can add those fractions together and get 17/21. Okay, so we haven't called them conversions, but we've multiplied by 1 in order to convert that to a different looking fraction, an equivalent different looking fraction, so we can add them together. We've done it again a little differently here. We've talked about how, I don't like it, I've said, but sometimes you're supposed to make fractions look polite. In my opinion, this is a great looking fraction here, but some of your teachers might want you to make this look polite. And the way to do that is, politeness, I guess, you can't have a radical in the denominator. Okay, I don't like it again, but so what we're going to do, cubed root of 4, I don't know the exact answer to, but I do know the cubed root of 8 is 2. So I'm going to force this to say the cubed root of 8 in the denominator, and the way we do that is multiply by 1. Notice the value here is 1, just like this is 1, this is 1. Okay, so the value here is 1, and so now when I multiply these, I get 4 cube roots of 2 over the cubed root of 8. And we know that the cubed root of 8 down here is 2, so I'm just going to rewrite that. 2. The value of the cubed root of 8 is 2. That's polite now, and that's a good looking fraction. We could take it one extra step and make it look real nice and say 4 over 2 reduces to 2 over 1. So 2 cube roots of 2. And again, the reason why we're doing this is just to connect what we've already done this year to where we're going now. So you're not going to have a problem as difficult as this today, but those of you that have had chemistry and have done unit conversions, you might have even done it before chemistry. You call it unit conversions in different settings. So this year, unfortunately, because of the coronavirus, the Olympics are canceled, the Summer Olympics. But 4 years ago, a young man from South Africa broke the 400-meter record. I'm a big 400-meter fan. That's one lap around the track. Michael Johnson, 20 years ago, broke the world record. I saw it happen, and I didn't think that was ever going to be broken. I think it was like 43.18 or something like that. But 4 years ago, this young man from South Africa broke the record. He ran one lap around the track in 43.03 seconds. So right now, this conversion here is in meters per second. So we could say this. His average speed as he went around the track was 9.296 meters per second. Us in America, this doesn't make as much sense to us. So if we want to convert this, we can convert it to miles per hour, and we can figure out what his average speed is. So down here I have a little bit of a conversion box. Okay, so if we want to convert that, we need to convert meters to miles, and we need to convert seconds to hours. And so you can do this a few different ways. It's all a matter of what you have in your head plus what I'm giving you here. Eventually I'm going to use this conversion here. So let's do this first. Let's convert meters to kilometers. And I'm going to use a value of 1 here. Top and bottom have to read the same, like this, this, this. Okay, so here's our unit conversion. I know that there's 1,000 meters in 1 kilometer. 1,000 meters in 1 kilometer. And I wrote it this way so the units are going to cancel. If I would have written it 1,000 meters over 1 kilometer, meters would not have canceled with meters if meters is on the top. So this allows that conversion to take place. Now our answer is in kilometers per second. Let's keep going here. Let's get this to miles though. I'm going to have another fraction here, same top and bottom, and I'm going to use this, 1 mile and 1.61 kilometers. So see if you can think about which am I going to put 1 mile over 1.61 kilometers, or am I going to put 1.61 kilometers over 1 mile? Remember, we want this to cancel. So where do kilometers have to be in order for this to cancel? Kilometers need to be down here. So 1 mile is the exact same distance as 1.61 kilometers. Notice they cancel. Now our answer is in miles per second. Lastly, we just need to get our seconds into hours. So do you know how many seconds are in an hour? Well, think about 60 seconds in a minute and 60 minutes in an hour. And so 3,600 seconds over 1 hour, or should I put 1 hour over 3,600 seconds? Look where seconds are here in the bottom. So where should seconds be in this? 3,600 seconds in 1 hour. Seconds cancel, and look at the units that are left, miles per hour. The last thing we just need to do here is take all the values in the numerator and divide it by all the values in the denominator. Watch how we use parentheses for this just to keep it organized. All the numbers in the numerator divided by, parentheses again, group that, all the numbers in the denominator. So 20.786 miles per hour. So that guy, I mean, he ran different paces throughout his race, 1 lap around the track. He didn't run that all the time. Sometimes he was a little faster than that, sometimes he was a little slower than that, but on average he was running a little over 20 miles per hour, which is pretty incredible for that. All right, moving on here. So I'm just going to show you maybe the first 2 here, and then the rest of this will be practice for today's assignment, guys, okay? So we're going to be using, let's see on this one, how many degrees are in 4.4 pi radians. So here's some conversions here. So we're going to start out with our known information. It's usually a good idea to start with, to show it as a fraction as well. 4.4 pi radians. And I'm going to write that over 1 so it looks like a fraction. Times, right here we're going to have our fraction that's a conversion. So you can use either one of these. I might use this one because the numbers are smaller. We know that 2 pi radians is a full rotation, 360 degrees. Half of that, half of 2 pi is 1 pi, and half of 360 is 180. So we can use either one of these conversions because these are the same thing. They both represent half a rotation. These both represent a full rotation. So think about it. Radians in the top in this conversion here, where should radians belong in this fraction to cancel? If radians are in the top here, radians should be in the bottom here. So I'm going to write pi radians, half a rotation, half a rotation, 180. So this is the same thing. It's like multiplying by 1. So let's see what happens here. Our radian cancels, our units. Notice the number pi, top and bottom, even cancels. And so our final answer, 1's in the denominator. So if we just take 180 times 4.4, 792, and what are the units that are left? Degrees. So think about that. 4.4 pi radians. Well, if there's 2 pi radians in a full rotation, 4 pi radians would be 2 full rotations. 4 pi, that's even more than 2 full rotations, so that's going to be more than 720 degrees, and it is. All right, next one here. How many meters are in 100 yards? I'll let you guys kind of mess around with that a little bit. If you have questions, stop by my office for office hours, okay? And I'll talk you through any of these. So here's your practice problems. Make sure you don't just Google this and say, how many meters are in 100 yards? If you just write an answer down, I'm not going to give you credit for this assignment. You need to show the unit conversion here, especially down here. Take some time to work through these. The process is the same as that. Make sure you show this value here in this work. I'm not going to give you credit if you don't. Okay? Good luck, guys.